The thumbkin twistin right-hand rule for magnetic field direction. The thumbkin twistin right or left-hand rule can be used to find the direction of the magnetic field lines for the field created by a moving charge. The way this rule works, and thumbkin twistin is simply what I call it, and I call it that so that I can remember what it is. The way you use it is you point your thumb in the direction of the moving charge. The direction of the magnetic field is then indicated by the way your fingers and wrist naturally curl. So we will demonstrate this. We will use the right hand rule for positive charges, and we'll use the left hand rule for negative charges. I'm going to back the camera out here so that we can see this ever so briefly. I call it the thumbkin twistin right-hand rule because you point your thumb in the direction that the charge is moving, and then whatever way your hand and fingers naturally want to curl, that's the direction that the magnetic field is going to have. And if we have a negative charge, we use our left thumb that goes in the direction of the moving charge, and the magnetic field lines are going to go in kind of orbital paths around this charge, so that we can refer to this without having to constantly put the camera in a different place. I've made this terrible model of a right-hand rule. RT stands for your right thumb. So what we have here, we've got your right thumb, and then you can see this little bent piece of metal that I've put in the piece of wood. That represents my fingers. I didn't have 4 pieces of metal, so I only had 1, like so. You put your thumb in the direction that the positive charge is moving. Whatever way your wrist and your fingers naturally want to curve, that's the way that the magnetic field is going to be directed. If we look at this picture right here, we can see that we have positive charge moving in that direction. And so we put our right thumb in the direction that that charge is moving, and then whatever way our fingers curl, that's going to be how the magnetic field is going. So you can see for that leftmost diagram, we're going to have magnetic field lines coming towards us on the left, and then it circles in front of the charge, and then on the right side, it's going to be going away from us. Something like this. We're going to have, I'm trying to indicate that the field lines are closer to us up here, and then they go behind. We've used our right-hand rule for that. If the positive charge is going in that direction, once again, we use our right-hand rule. I'll use my real thumb for a second. We're going to point that down, and then you can see on the left, we're going into the page now, and then on the right, we're coming out. We're coming out like this, and then on the left, we're going into the page, kind of like so. And I'm only drawing a couple of field lines here, because obviously we don't have space to draw all of them, something like that. We point our right thumb in the direction that the charge is moving, and on the right side, the field is coming towards us, and then on the left side of that wire, the field is going away. Let me zoom in closer. We use the same idea for moving electrons. We could have a beam of moving electrons, or we could have just one electron. It doesn't matter, but we need to use our left-hand rule. So we need to use our left thumb and then our fingers. So then we curl like so. Field lines, in the case of this diagram right here, we put our thumb in the direction that the electrons are moving, and you can see that the field is coming towards us on the right, and then on the left side of that beam, it's going to be going into the page. We're going to have something kind of like that right there. Let me draw another one, like so. Kind of like planets going around the sun. They are continuous lines. And lastly, for this one, left thumb points down towards the bottom of the page, and the field lines are going to be coming towards us on the left, and they're going to be going away from us on the right. And these field lines exist all the way up and down this line of moving charge. But that is basically what's happening with the thumbkin twistin right-hand rule or left-hand rule if you have negative charges.